This project can be divided into 3 parts: hardware, software, and application. In terms of hardware, the participants include Professor and Director Guo Mao Kun, Professor Wu Wenzhong, Professor Yang Yao Zhou, Professor Shi Wen Bin, and Professor Lin Zhiting. Our working projects and achievements have involved the design of the battery power supply model of the simple node and the super node. We are able to mass-produce 300 simple nodes and 100 super nodes to reduce the complexity of setup. In regard to the super node battery, we provide high-capacity EEPROM and micro SD sockets. We have built the light, temperature, and humidity sensor, and we have designed the tiny size simple node for a full censored environment. The following models have been used successfully in intelligent life and safety care environments. In regard to software, the participants include Professor Rui-Yi Zhang and Professor Jiankang Huang. This project has the 5 following functions. 1. Assets management. Since the usage of equipment in the server room is recorded in the database, we can provide anomaly alerts to prevent theft. 2. Network management. In network management, we can access WSN topology to make sure each sensor node is working normally. In addition, we provide a security mechanism for transmission. 3. Entrance security and surveillance. We have integrated entrance security with surveillance to monitor activity in the server room. 4. Power system. By monitoring the power status of each device, we can immediately alert the administrator if there should be a problem with power. 5. Environmental monitoring. By monitoring temperature, humidity, and luminosity, we can provide real-time environmental information for the administrator. In regard to application, the participants include Professor Polly Huang, Professor Fu Li Zhen, and Professor Zhu Hao Hua, Professor Chuin-Shan, and Professor Xiao Zijian. In order to apply developed WSN technology to real life, we simulate several scenarios: smart living, indoor locating, and bridge structure security monitoring. WSN applications and scenarios for smart living. Ray is a white-collar worker and he shares responsibility for taking care of his grandfather with his wife. His grandfather suffers from some common elderly-related health problems such as BHP, benign prostatic hyperplasia, and HBP, high blood pressure. In addition to their heavy workload, these 2 relatively young persons often need spare time to look after their grandfather. Grandpa often has to wake up to go to the restroom at night because of his age. In addition to its location being monitored by wireless sensors, the smart home system incorporates information derived from various wireless sensors to monitor Grandpa's ongoing activities. As a result, WSNs help to document Grandpa's daily activities so that the technology alleviates the responsibility of taking care of Grandpa from Ray and his wife. Scenarios of indoor locating. Applying the indoor locating application of WSN technology, we can locate the real-time position of the user and use it as a receiving platform for sensing network information. For example, it can monitor data for vital signs such as heart rate and skin temperature of patients or the elderly when they are in the hospital or at home. In this way, the system can send the information back to the server, and thus accidents can be prevented before they occur. This system can support multi-users without obstructions via multi-hop routing. There are 2 components to this system: the infrastructure side and the user side. The user side is a wearable, low-cost module. Scenario of bridge structure security monitoring. The Jilu cable bridge is one of the most important bridges which connect Jiji and Lugu. Around the time when construction was completed on this bridge, it was damaged by the notorious 9/21 earthquake of 1999. There are rare case studies of cable-stayed bridges being reformed after earthquakes worldwide, and this bridge attracted a great deal of attention following the 9/21 earthquake. By providing persistent verification of security and monitoring of the bridge's condition to prevent unexpected catastrophes in the future, the wireless sensor network platform developed in this project provided a flexible, efficient, simple, and low-cost solution.